All right, let's jump right in. We're about to pull back the curtain on something that's, well, one of the most powerful yet kind of invisible forces in our modern world, the database.
I mean, have you ever stopped to think about it? From the stuff sitting in your online shopping cart to your entire search history, everything you do online creates data. But how do we keep all that information from just turning into a digital black hole of total chaos? How does it all stay organized and safe and ready the second you need it? Well, that is the exact problem databases were invented to solve.
So let's hop in a time machine and go back to the 1960s. Before we had databases, every single computer program had its own private stash of files. Seriously, imagine an office where every employee keeps their own separate copy of every document. It was a complete and utter mess. You had massive data redundancy, the same info copied over and over in dozens of different places. And that, of course, led to rampant inconsistency. If you updated one file, whoops, all the others were instantly out of date. It was just a terribly inefficient way to get anything done.
And this image here, man, it just says it all. Look at this tangled web. Each of those boxes is an application, and they're all pulling from their own little islands of data. Little isolated silos. There was no central source of truth. So trying to get a complete picture of, well, anything was an absolute nightmare. This was a recipe for chaos, and it was seriously holding back what computers could actually achieve.
But then, a hero arrived on the scene to bring some much-needed order to all this chaos. This was the dawn of the Database Management System, or DBMS, revolution.
So, what exactly is a DBMS? Well, think of it as a super smart software system. It's designed to manage these huge collections of data that are shared by tons of users and applications. And that data needs to stick around, permanently. The key thing to get here is that it's not just storage, it's an intelligent manager of that storage.
And this manager has some serious superpowers. First up, reliability. It makes sure your data is never lost or corrupted. Simple as that. Next, privacy. It acts like a super strict bouncer at a club, controlling exactly who gets to see or change what. And finally, incredibly efficient access. It lets applications find the one tiny piece of information they need in a fraction of a second, even if it's buried among billions of other records.
So this right here is the after picture. Instead of that tangled mess we saw before, now all the applications go through one central gatekeeper, the DBMS, to get to a single unified database. This one simple-sounding change brought structure, security, and just plain sanity to the entire world of data.
Now you have to understand, a great database doesn't just happen by accident. Oh no, it requires a really disciplined, structured design process. It needs a blueprint that takes you all the way from a simple idea to a fully functioning system. And that whole process is usually broken down into 3 key phases. First, you've got the conceptual design. That's where you figure out the big picture idea. Then comes the logical design, where you translate that idea into an organized plan, or what we call a schema, which is basically the blueprint for how your data is structured. And finally, there's the physical design, where you decide exactly how that data is going to be stored on a disk to be as efficient as possible.
What's really interesting here is how much emphasis there is on that very first step. The conceptual design phase is so critical because it forces you to think about the information itself, the real-world people, places, and things you want to keep track of, completely separate from any specific software or hardware. You're basically building a pure, technology-free blueprint of your world.
And this slide shows that whole translation process in action. So on the left, we've got the abstract blueprint. It's called an entity relationship diagram. It's just boxes and lines showing concepts like students and courses and how they're connected. Then on the right, you see how that blueprint gets turned into the logical design, a clean, organized set of tables. This is the magic step, turning a high-level idea into something a computer can actually understand and manage.
So for decades, this model of structured tables, the relational model, it ruled the world. We talked to them with a language called SQL, and for a very long time, it was pretty much perfect. But then the internet exploded, right? And with it came this explosion of messy, unpredictable data from companies like Facebook and Google, and that created new challenges that the old model just couldn't handle. The sheer scale, the speed, it was breaking the system. It was time for another revolution.
And as you can see on this timeline, after a really long period where relational databases were king, something new started to pop up around 2005. A whole new category of databases designed for the scale and complexity of the modern web. They called it NoSQL. So, what's the core difference? Well, relational databases are all about structure. Think of them like a perfectly organized spreadsheet. They enforce a really rigid schema of tables and rows, which is awesome for consistency. NoSQL databases, on the other hand, are all about flexibility. They often don't have a fixed schema at all and store data in these more fluid structures, like documents, which can easily adapt as your needs change.
And NoSQL isn't just one thing. It's a whole family of different approaches. You have simple key value stores, super flexible document stores, really efficient column stores, and even graph databases that are perfect for modeling complex relationships, kind of like a social network. Each one is specialized for a different kind of problem.
And this is where it gets really cool. Just look at this example from a document database. An entire student's profile, their name, a list of their exams, their contact info, it's all contained in one single, self-contained document. This nested structure is not only a much more natural way to represent real-world things, but it's also incredibly efficient to pull up. You ask for the student, you get everything you need in one go.
So this all brings us to the big question for the future of data. We started with chaos, we found order in the rigid structure of relational databases, and now we're exploring this incredible flexibility with NoSQL. So, what's next? Will one model eventually win out, or is the future actually a hybrid world where we just use the right tool for the right job? That is the challenge and the opportunity for the next generation of data pioneers.